Hi guys, we're about to finish this. We're gonna work on lesson 21.6 today, which is volume of other solids. And we are just going to be ending chapter 21 along this next couple lessons, alright? Volume of other solids is not really difficult if we keep in mind the characteristics of prisms and pyramids, alright? Now for prisms, please keep in mind the formula. Volume is always equal to base area times height. Now, base area, it's of course, remember we have two bases in a prism, right? So we only need to find one of those bases. The area of those bases. And then we're just gonna multiply by the height. That way we're gonna be able to find the entire volume. Now, if we needed to find either the base area or the height, when we are given the volume, it's only a matter of just isolating the equation for the dimension we don't know. So if we need to find the base area, we're just going to divide the height on the other side. So we get volume divided into height equals base area, right? Or if we want to find the height, we just have to divide base area divided into volume. So it's all a matter of making sure if we have problems that don't ask you to find the volume, but to find the base area or the height, you would have to use either of these two, okay? Now in the case of pyramids, we're gonna think about those in a little bit. I just wanna show you a couple exercises in regards of prisms first, okay? We are going to talk about this triangular prism. Again, we know we have two bases. We can see them right here. And we have the height over here. Now, if you think about the volume in a prism, if you want to understand how it works, it all is about just making sure that we have like slices of triangles just piling up upwards, right? And that would be the volume. So we have triangles piling up upwards, and that would give us the volume. How am I going to find this volume? Well, it's pretty simple. Just think about the formula. And of course, we need to find the base area first. So on a side over here, we're gonna find the base area. Now the base area, as you can tell, is a triangle, but it's a right triangle. So we know the formula to get the area of a triangle, it's actually base times height divided in 2. And since we have a right triangle, we know the base is gonna be this one and the height is gonna be this one. So we have 5 times 6 divided in 2, which of course is 15 square centimeters. So we're gonna work with that, okay? So here, we're gonna have 15 centimeters times the height, which of course is 10, and that's gonna get us into 150 cubic centimeters, okay? That's one exercise I wanted to show you about prisms. Now think about a cylinder. Remember, cylinders are just the same as prisms, but they just have infinite faces, right? That's what a cylinder is. So we want to think about that cylinder right there. How are we going to think of the volume here? Well, same thing. Think of the volume as the base area times the height. Again, I have, circular slices that are going to pile up upwards so we can fill out the space, and that's what the volume is going to mean. And first of all, we're going to find the base area. Now, we have a circle, so we cannot forget the area of a circle, right? And then we're going to, of course, put the numbers we know. So we know pi is going to be, of course, approximated to 3.14, and then the radius, here we have an entire diameter, remember? So one diameter is always 2 radiuses. Please keep that in mind. So what that means is that the radius is not going to be 18, but actually 18 divided in 2, which is 9. Right? And then so we have 3.14 times 81. And that, I already did my math, so it's 254 times 34 square inches. Right? I'm going to use that, of course, over here. So I'm having 254.34 times the height. In this case, the height is 4. So we're going to multiply those two things, and I actually got 1,017.36 inches, cubic inches. Now, please don't forget that for volume, we use cubic units. So cubic centimeters, cubic inches, okay? All right, now let's think about pyramids. In terms of pyramids, let me erase over here pretty quick. In terms of pyramids, guys, we're going to think about what the volume of a prism is, but always divide it into 3. So here, as you can tell, the formula here is going to be same base area times height as we had it with prisms, but we're going to divide it into 3. And why is that possible? Well, because we are having not parallel faces, right? But all lateral faces now are going to encounter the vertex that we have against the base. So that makes all the volume to reduce to 1/3 of whatever equivalent in the prism we had before. If we think about that, then we need to figure out what height are we talking about here. Because the height here, we actually have 2 types of heights in pyramids. So we gotta be careful about that. But what we really wanna know here, the height, is how tall the entire pyramid is, right? So we gotta think about the center of the pyramid and going up until the vertex. And that's what we have to think about when we see the height here in pyramids. If you are given the volume, but they're asking you to find the base area, again, you have to isolate base area for it, right? What that means is that I need to, this 3 is divided here, so I gotta make it multiply on the other side, right? And then the h is going to be divided on both sides, so I get h to divide here. I isolated the formula. So what that means is that to find the base area, if they give me height and volume, I just need to multiply the volume times 3 and divide it by the height. Same thing when I need to find the height. I gotta isolate the entire formula for the height. So again, the 3 gotta go and multiply with the volume, and then that base area is now going to divide here. So I get the h to be alone, right? Those, you manage those type of changes in the formulas when they give you the volume, but they ask you to find either of these 2. That's what you gotta keep in mind. Think about this pyramid here. Now, again, the height is how tall the pyramid is. So I need to think about the center of the pyramid and go upwards until the vertex of the pyramid. That would be my height. That's why we call it the perpendicular height, because it goes all straight and it's perpendicular to the base of the pyramid. Now, if we think about this specific example, I know it's going to be base area times the perpendicular height divided in 3, and they give me several measurements. Now, I need to find the base area first, of course, as before. This is a rectangle, so we know its length times width, which is 14 times 6 or 6 times 14, depending on how you see the rectangle, right? And that, of course, is going to be 60 and 24, that is 84 actually, square meters. So here I'm going to have the base area, which is 84 times the height. As you can tell, the height here is 8 divided in 3. Now, as you know me, I'm going to just simplify over here. And I know 84 very quickly. I'm going to divide it over here, and it's 2, 2, 4, 8. That's it. 8, because then I get the 0 here, right? So it's going to be 28. And I know 28 times 8, it's going to be, sorry, I didn't do that one, so I'm going to do it over here very quick. 8 times 8 is 64. 16 and 6, that is 22. So it's 222 cubic meters. And that's going to be our volume here in the pyramid, okay? Now, that's for pyramids, but again, please remember the general way to see a pyramid is actually a cone. So if we think about a cone like this, how can we find the volume of a cone? Same thing, right? Same thing. The only thing that changes is that now I'm dealing with circles. And of course, circles are gonna give me a little bit of trouble because I need to deal with pi, right? But it's not really that complicated. Now let's find the base area. Again, it's gonna be pi times the radius squared. And of course, pi is gonna be approximated to 3.14, and the radius here clearly is 8. So we know it's 3.14 times 64. And then 64, I think I did that one. Let me see. Yes, I did. So it's going to be 200.96 square yards, because we have yards in this exercise. And with that, now I'm going to replace all the information I have to find the volume. So it's 200.96 times the height, which is 12. Again, is the perpendicular line, height, which is how tall the cone is. And I gotta think about the center of the circle going all the way up until the vertex of the cone. This, of course, gonna be divided in 3, which is good because I can simplify over here. And I know that's gonna give us less than 1,000, right? Actually, I'm getting 803.84 cubic yards. That would be how to find the volume of a cone. How about we find volumes of solids that are not specifically prisms or pyramids? That means they are compound solids. Remember, as we were finding the area of compound shapes before, now we're gonna find the volume of compound solids. So think about this little ring, if you wanna call it like that. For me, it kind of looks like a lifesaver lollipop that we used to have as kids when we wanted candy. And so what we are going to deal with is how can we find the volume of this solid, because it's not a cylinder, because it has a hole in it, right? Now, for those who already thought about getting the solid of one big cylinder and then the volume of one cylinder and then the volume of the cylinder that is actually the hole and then subtract it, you're right. That is exactly what we're gonna do. Think about, and I'm gonna probably think about the bigger cylinder as B1, okay? And then this smaller one is gonna be B2. So the total volume here is going to be what? Well, V1 minus V2, right? I need to find both of those, of course. So let's find V1 first. Again, it's a cylinder. If it is a cylinder, it's a prism. If it is a prism, I need to find volume equals base area times height. So I'm going to use that. And that gets me into the base area, which is a circle. I need to find it on the side. So I'm going to do it over here, right? Which is, can you see that? Probably not. Let me do it again, right? And then, of course, that's going to be 3.14 times, and the radius here is a little bit tricky. Why? Because if you think about it, they're telling us that this part is actually 8 inches. And this part is actually 8 inches. I know it doesn't really look like they're the same, but that was my best effort trying to draw that, okay? And so if I want to find the radius of the bigger circle, then I need to go from the center outwards to the circumference. So I actually need to find this length, right? And this length is 8 inches up to here. But if this distance is actually 8 inches, then the half of it should be only 4. And if I add those 4 with this 8, that would be 12. So I need to think about a radius of 12 inches here. Okay? And I actually did that one. Give me a minute. I just don't know where is it at. Oh, over here. So it is actually 452.16 square inches. Okay? That is the base area. I'm going to use that over here, of course. So that's going to be 452.16 times what? The height. Now the height is how thick the solid is, of course. And so I'm thinking about 2 inches right now. That is, of course, a little bit more than 900. 904.32 cubic inches, of course, right? So that's one. Then I'm going to do the second volume. The second volume, again, is another cylinder. It is just a little bit smaller. And that second volume, of course, has a base area that is also a circle. And that circle has a radius. Sorry, I'm going to do the 3.14 right away. That has a radius. If you think about this, this is going to be the smaller circle I want to think of, right? This distance is 8, which is the diameter. I want to think about that 4 right there. That's going to be my radius. So 4 squared, okay? And that's going to be 3.14 times 16, which I did, and that gave me 50.24. And that is square inches, of course, right? I, of course, use that over here times the height, which is 2, and this one is too easy, 100.48 cubic inches. Now, if we think about the total volume again, we know the total volume here, it's going to be volume number 1 minus volume number 2, and volume number 1, of course, was 904 times 32 minus 100.48, and so that gets me into 800 something, right? 803.84 cubic inches. So this is my answer right here, guys. All right? Now, if you think about it, it's all what we had actually done before with areas, but now we're just applying it to volume, and that's it. Problems in the lesson are not really difficult if you keep in mind how to find different dimensions, all right? And if you read carefully in terms of trying to determine what type of volume they're asking you to find, whether it's a pyramid or a prism. Cones and cylinders included for sure. I'll see you later for our last lesson of the school year. Have a wonderful day. Bye.